Welcome to this explainer. Today, we're jumping straight into the incredible science behind a seemingly simple, unremarkable black substance. But trust me, it's quietly transforming modern agriculture, literally from the molecular level all the way up to massive commercial harvests. We're talking about a powerhouse organic compound that actually has the potential to heal our soils and completely secure our future food supply. Let's get right into it.
So I want you to just think about this for a second. What if a basic, highly soluble black flake could boost your crop yields by almost a quarter? Now I know that sounds like magic or maybe some ultra-aggressive synthetic chemical, right? But it's actually an ancient, naturally derived organic fertilizer. Today we're going to unpack the massive, scientifically proven impact this stuff has on plant growth.
And look, we aren't just dealing in hypotheticals or marketing fluff here. We're grounding these bold claims in actual, certified chemical analysis and peer-reviewed agronomic research. The certificate of analysis guarantees that exactly what goes into the soil meets incredibly rigorous specifications. So there's no guesswork involved. It's just hard, verifiable science.
Okay, here is our roadmap for today. First, we'll meet potassium humate. Then we'll look at supercharging plant photosynthesis, followed by the yield-boosting formula. After that, we'll check out a real-world application with tomatoes and wrap up with sustainable farming solutions. All right, Section 1, meet potassium humate. The first thing to notice here is the sheer density. We're talking about a minimum of 80% organic matter packed into this stuff. It features super high concentrations of humic acid and fulvic acid, plus a 12% boost of potassium oxide, which delivers that essential potassium right to the plant. And also keep that high pH level of 9 to 10 in mind. That highly alkaline nature is going to become incredibly important later when we talk about healing acidic soils. And hey, just a quick aside, while we're focusing mostly on these fast-acting soluble flakes today, potassium humate also comes in granule form, and those granules are absolutely phenomenal for long-term soil structure improvement. Definitely something to keep in your agronomy toolkit. But getting back to the flakes, their defining physical characteristic is that they are completely water-soluble. And this isn't just a nice-to-have feature, it's honestly the absolute key to modern application. Because it dissolves entirely without leaving any sludgy residue, farmers can integrate these dense nutrients straight into high-tech drip irrigation or foliar spray systems. It shoots the nutrition immediately into the plant system without clogging up incredibly expensive farm equipment. And saving the equipment is always a massive bonus. Moving right along to Section 2, supercharging plant photosynthesis. So researchers decided to test various concentrations of potassium fulvic acid, which is a key component of what we're talking about, by spraying it directly onto the leaves of corn seedlings. They compared a control group getting 0 milligrams against various doses scaling all the way up to 500 milligrams per liter. The vital takeaway here? More is not always better. The 100 milligrams per liter concentration, labeled as H100, proved to be the absolute biological sweet spot. Actually, when they pushed it all the way up to 500 milligrams, it caused stress and actively inhibited the plant's growth. But when applied at that optimal H100 concentration, the results were wild. The net photosynthetic rate of those corn seedlings shot up by 37.74% compared to the control group. That exact formulation literally supercharges the plant's innate ability to capture sunlight and convert it into usable energy for rapid growth. And the H100 treatment didn't just boost the energy conversion, it actually increased stomatal conductance by over 93%. If you want to visualize that, think of it like opening up the plant's lungs. It literally forces the microscopic pores on the leaves to open wider, allowing the plant to breathe in way more carbon dioxide and just completely accelerate its entire metabolic rate. Okay, Section 3, the yield-boosting formula. Let's see what this means for the harvest. Now, here is the number that is making agricultural economists and commercial farmers really pay attention. When potassium humate is applied optimally, meaning they are soaking the seeds and spraying the leaves, researchers documented a massive 24.79% increase in total corn yield, almost 25%. That is an absolute game changer for overall food production and, of course, farm profitability. And the data breaks down exactly where that extra 25% is coming from. The plants aren't just magically producing more ears of corn. The entire morphology of the plant is beefed up. We're seeing taller plants, noticeably thicker stems that can physically support more weight, and ears that are almost a full centimeter longer. But my absolute favorite metric here? The bare top rate decreased by over 3%. That means fewer of those annoying, empty, undeveloped spaces at the top of the corn cob. every single plant just becomes a total model of efficiency. Next up, Section 4, Real-World Application, Tomatoes. Now, you might be wondering how this actually works out in the field. Well, it isn't just some abstract lab theory. It's a highly standardized farming method. Step 1. Before they even plant, farmers lay down water-soluble drip tape under the mulch. Step 2. They deep plow the soil 20 to 30 centimeters down with a base fertilizer. And by the way, this plowing stage is exactly where those potassium humate granules we talked about earlier really shine, physically improving the soil structure right down at the root zone. Then step 3, just 7 days after planting, they top dress with the water-soluble flakes. Finally, step 4, right as the tomatoes hit their crucial fruit swelling stages, they pulse this nutrient mix through the drip lines sequentially. It guarantees the plants have exactly what they need right when they need it most.
Let's move to our final section. Section 5, Sustainable Farming Solutions.
So we have to acknowledge that modern intensive farming has a pretty dark side. When we plant the exact same crops in the exact same soil year after year, we severely degrade the soil microbiome. It creates what agronomists call a continuous cropping obstacle, which essentially means we are exhausting the soil's immune system. And it is incredibly severe in medicinal plants. Roughly 70% of tuberous medicinal crops face this exact issue. The stressed plants release exudates that literally turn the soil acidic, which then invites in soil-borne pathogens and completely stunts any future growth. It's a vicious cycle.
But thankfully, there is real hope. As highlighted recently in the Chinese Journal of Eco-Agriculture, researchers are actively figuring out how we can fight back. Because potassium humate is highly alkaline, remember that pH of 9 to 10 we flagged earlier, and incredibly rich in organic matter, it acts as a very powerful ecological intervention. It actively buffers that harmful acid, feeds the beneficial microbes, and helps rebalance and heal the damaged soil food web from the bottom up. Which leaves us with this final thought to chew on. We've spent decades and decades relying on really harsh, synthetic interventions to force our crops to grow. But the data clearly shows that returning to high-quality, highly refined organic matter, like potassium humate, can not only boost our immediate yields, but actually repair the very earth we rely on. So how else can we leverage the ancient biology of the past to secure the vulnerable food systems of our future? I really hope this explainer gave you a brand new perspective on the complex ground right beneath our feet. Thanks so much for watching.